In the grand and often chaotic story of our human lives, there are very few things that we can truly count on. But for all of our recorded history, and for the entire existence of our species, one great and beautiful constant has remained. It is the rising of the sun. Every single morning, without fail, our star returns to us, bathing our world in its life-giving warmth and light, chasing away the darkness and making our continued existence possible. The sun is the ultimate symbol of permanence, of reliability, and of life itself. It is the great golden anchor of our world, the heart of our solar system, the engine that drives our seasons, our weather, and our very biology. It feels eternal. It feels absolute. And yet, one of the most profound and beautiful truths that science has ever revealed to us is that our sun, like every other star in the sky, is not an eternal object. It is a living, breathing, and dynamic entity, and it has a life story. It was born. It is currently living through a long and stable middle age, and one day, in the deep and distant future, it will die. The story of the sun's final days is not a story of a sudden and unexpected apocalypse. It is not the tale to be feared. It is, instead, a grand and majestic cosmic biography, a story of profound and beautiful transformation that is written in the fundamental and unchanging laws of physics. To understand the death of our star is to understand the life of all stars. It is a journey that will take us billions of years into the future. To witness a sky that is almost unimaginably different from our own, we will see our familiar yellow-white sun swell into a colossal red giant, a star so large it will consume the inner planets. We will witness the final, beautiful, and ghostly act of its life as it sheds its outer layers to create a magnificent and intricate jewel of glowing gas in space. And we will see its final, quiet retirement as its cooling heart becomes a small and fading ember, destined to slowly disappear into the great, final darkness of the cosmos. This is the sun's final story. And it is a story not just of an ending, but of a great and beautiful cosmic renewal. Before we begin this epic billion-year story, I would love to know from which part of our own sunlit world you are joining us tonight. Please write your city or country in the comments below. It is a quiet way to feel our shared connection, a global community of curious minds, all living our lives under the light of this one single magnificent star. And if you enjoy these calm and deep journeys into the heart of the cosmos, please consider subscribing to the channel. Your support is the energy that allows this exploration to continue, always calmly, always at the pace of the universe. The story we are about to tell is a long and a patient one. The end of our sun is not an event that is imminent. It is a destiny that lies some 5 billion years in our future. But the script for this final act has already been written. The fate of a star is determined by a single, simple factor: its mass. And because we know our sun's mass with incredible precision, we can predict its future with a quiet and profound confidence. Our journey tonight will be a calm and detailed exploration of that future. We will begin with the long and peaceful era of the sun's current life, its stable and life-giving main sequence. We will explore the delicate balance of forces at its heart that have allowed it to shine steadily and reliably for the last 4.5 billion years. From there, we will travel forward in time to witness the first subtle signs of its old age, the moment when the hydrogen fuel in its core finally begins to run out. We will see how this event triggers the great and dramatic transformation into a red giant. We will then turn our gaze back to our own Earth to witness the fate of our own world as it is bathed in the intense heat of this new colossal sun. We will then follow the sun through the final, beautiful, and often violent stages of its life, as it fuses new elements in its heart and then gently puffs its own substance out into the void, creating a breathtaking planetary nebula. And we will end our story with its final, quiet form, a small, dense, and slowly cooling white dwarf, the stellar corpse that will be the Sun's final, silent monument. Let us now begin this great story, not at the end, but here, in the long, quiet, and peaceful afternoon of our own star's magnificent life. To understand the eventual death of our sun, we must first come to a deep and quiet appreciation for its long and beautiful life. The story of a star's end is written in the details of its existence. And for our sun, its current existence is one of profound, almost unimaginable stability and peace. It is in a phase of its life that astronomers call the main sequence. This is the long, quiet, and stable adulthood of a star, the period in which it spends the vast majority of its existence. Our sun has been in this peaceful state for the last 4.5 billion years, and it will remain here, shining with a gentle and reliable constancy for another 5 billion years to come. It is this very stability, this long and unbroken peace, that has been the greatest of all gifts to our own planet. It is the steady, nurturing warmth that has allowed the slow, patient, and beautiful story of life on Earth to unfold. Let us now, in our minds, take a journey into the heart of this great and peaceful star. We begin at its visible surface, a layer called the photosphere. It is a roiling, boiling sea of plasma, with a temperature of around 6,000 degrees Celsius. But this is just the cool outer skin of the sun. As we descend deeper, the pressure and the temperature begin to climb at a rate that is difficult for our minds to comprehend. We pass through the great churning convection zone, where vast currents of hot plasma rise and fall like water in a boiling pot. Deeper still, we enter the radiative zone, where the energy is so intense that it travels as high-energy photons, taking hundreds of thousands of years to bounce their way from one atom to another on their long journey outwards. And finally, after a journey of hundreds of thousands of miles, we arrive at our destination. We have reached the core. The core of our sun is a place of almost impossible extremes. The temperature here is a staggering 15 million degrees Celsius, and the pressure is more than 250 billion times the atmospheric pressure here on Earth. The matter here is in a state that is unlike anything we know. It is a plasma, a soup of atomic nuclei and free-floating electrons, crushed together to a density that is more than 150 times the density of water. And it is here, in this unimaginable cosmic furnace, that the sun's great, life-giving engine is at work. It is here that the sacred and patient alchemy of nuclear fusion takes place. Every single second, in the heart of our sun, a colossal amount of the most abundant element in the universe, hydrogen, is being converted into the second most abundant element, helium. This is not a simple one-step process. It is a slow and delicate three-step dance known as the proton-proton chain. It begins with two protons, the nuclei of hydrogen atoms. In the immense heat and pressure of the core, these two particles are able to overcome their natural electrical repulsion and they fuse together. In this instant, one of the protons transforms into a neutron, releasing a tiny, ghost-like particle called a neutrino, and creating a new, heavier nucleus called deuterium. This deuterium nucleus then collides and fuses with another proton, creating an even heavier nucleus, a form of helium known as helium-3. The final step of this beautiful dance is when two of these helium-3 nuclei, forged in previous steps, collide and fuse together. In this final, creative act, two spare protons are kicked out to begin the dance anew, and what is left behind is a single, incredibly stable, and perfectly formed helium-4 nucleus. And here we find the secret of the sun's energy. If you were to take the mass of the four individual protons that began this journey, and you were to compare it to the mass of the one final helium nucleus that was created, you would find that the helium nucleus is just a tiny fraction of a percent less massive. A small amount of mass has, in the process of fusion, gone missing. And this missing mass has not been destroyed. It has been converted directly into a pure and brilliant burst of energy, precisely as described by Einstein's great and elegant equation, E equals mc squared. This is the energy that pushes outwards from the core. This is the energy that, after its long and winding journey to the surface, finally radiates out into space as the sunlight that warms our world. And this outward-pushing energy is one half of a great and perfect cosmic balance. It is in a state of hydrostatic equilibrium. The immense crushing force of the sun's own gravity is constantly trying to pull all of its mass inwards, to collapse the entire star down into a single point. But at the same time, the immense outward-pushing pressure from the nuclear fusion in its core is fighting against this collapse. These two colossal and perfectly opposed forces are in a state of exquisite and delicate balance. Gravity pulls in, and the fusion furnace pushes out. And the result is a perfectly stable, perfectly spherical, and perfectly reliable star. This is the secret of our sun's long and peaceful life. And the great story of its death will be the story of what happens when this ancient and beautiful balance is, finally and inevitably, broken. We have established the beautiful and delicate peace that currently defines our sun. It exists in a state of almost perfect equilibrium, a magnificent and stable engine that has provided our Earth with a constant and reliable source of energy for more than 4 billion years. This long and quiet peace, this main sequence, is the great central chapter of the sun's life. But no star, no matter how great, is eternal. Its life is dictated by the finite amount of fuel it holds in its core. And while the sun's fuel supply is immense, it is not infinite. The story of the sun's death, therefore, does not begin with a sudden and dramatic event in the far distant future. It begins with a slow, a gentle, and an almost imperceptible change, a process that, in a very real sense, has already begun. This is the story of the sun's slow and inevitable brightening. The great engine in the heart of our sun, the process of nuclear fusion, is a beautifully self-regulating one, but it is not perfectly static. As we learned, the sun is constantly converting hydrogen into helium in its core. This helium, the ash of the fusion reaction, is denser than the hydrogen that came before it. And so, over billions of years, this helium ash slowly accumulates at the very center of the sun's core. As this dense helium-rich region grows, the core itself begins to slowly contract and to heat up under the immense, crushing weight of its own gravity. This slow increase in the core's temperature and pressure has a direct and profound consequence. It causes the rate of the hydrogen fusion reaction to increase. The sun's great nuclear furnace is, in a sense, slowly and automatically turning up its own thermostat. A higher rate of fusion means that more energy is being produced in the core, and this extra energy, over a very long and patient journey, eventually makes its way to the surface. And the result is that the sun's overall luminosity, its total brightness, is slowly and steadily increasing over time. This change is far too slow for us to notice in our own brief lifetimes. The rate of increase is only about 10% every 1 billion years. But on the geological and biological timescales of our planet, this gentle, creeping change is one of the most powerful forces of all. It is a quiet and ticking clock that is counting down the final, habitable days of our own world. We can see the evidence of this in the deep past. 4 billion years ago, when life on Earth was first beginning, the sun was about 30% dimmer than it is today. The fact that the early Earth was warm enough for liquid water, despite this fainter sun, is a famous scientific puzzle known as the faint young sun paradox. But now, let us turn our gaze forward. Let us use this same steady rate of brightening to create a long-range forecast for the future of our planet. For the next few 100 million years, the Earth's complex climate system will likely be able to adapt to this slow increase in solar energy. But as we approach 1 billion years from now, our planet will reach a critical and irreversible tipping point. By that time, the sun will be a full 10% brighter than it is today, and that extra, gentle warmth will be enough to trigger a catastrophic Rutherford feedback loop here on Earth. The oceans will begin to evaporate at a much faster rate, filling the atmosphere with a huge amount of water vapor. Water vapor is a very powerful greenhouse gas, and this thick, humid blanket will begin to trap more and more of the sun's heat. This, in turn, will cause the oceans to evaporate even faster, creating even more water vapor and trapping even more heat. This is a runaway greenhouse effect. Over the course of many millions of years, this process will, slowly and inevitably, boil our planet's oceans completely away. The Earth, our beautiful blue and white jewel, will become a dry and sterile desert world. The water vapor that once filled our oceans will now be in the atmosphere, where it will be exposed to the sun's intense, high-energy radiation. This radiation will break the water molecules apart into their constituent atoms of hydrogen and oxygen. The light, nimble hydrogen atoms will then escape the pull of Earth's gravity and be lost to space forever. The water of our world, the single most essential ingredient for our own existence, will be permanently erased. Long, long before our sun ever begins to swell into a red giant, its gentle, increasing warmth will have already transformed our Earth into a ceilingly hot, dry, and completely lifeless world, a barren and desolate twin to the planet Venus. The story of the sun's brightening is the story of the slow and relentless migration of the habitable zone. As the sun becomes more luminous, the temperate Goldilocks region that can support liquid water will slowly move outwards. In 1 billion years, the Earth will no longer be within this zone. The new, habitable region will have moved farther out in the solar system, perhaps to the orbit of Mars. And so, the very first act in the great final story of our sun is not a dramatic and fiery explosion. It is a long, a slow, and a quiet fever, a gentle increase in warmth that will, over the next billion years, be the silent and inevitable end of all life on Earth. We have now seen the long and quiet prelude to the end of our world. We have journeyed 1 billion years into the future and have witnessed the slow and gentle brightening of our sun, a creeping fever that will eventually boil away our oceans and render our planet a sterile and lifeless desert. This is the fate of the Earth. But the story of the sun itself, the great personal biography of our star, has a much more dramatic and transformative chapter yet to come. The true beginning of the end for our sun will not occur for another 4 billion years after the Earth has lost its oceans. We must now travel forward in our minds to that distant and momentous epoch, some 5 billion years from our present day. Let us go to the moment when the sun's long, peaceful, and 10 billion year-long adulthood finally and irrevocably comes to an end. For the last 4.5 billion years, and for the next 5 billion years to come, our sun has been and will be a model of stability. As we have learned, this stability is the product of a perfect and delicate balance, a state known as hydrostatic equilibrium. At every single point within the Sun, two colossal and perfectly opposed forces are fighting each other to a perfect standstill. The first force is gravity, the immense mass of the Sun itself, a mass that is 333,000 times that of the Earth, is constantly trying to crush the entire star inwards, to collapse it into an ever denser ball under its own relentless weight. But this immense inward crush is perfectly counteracted by a second, equally powerful outward force. This is the thermal and radiation pressure that is generated by the great nuclear furnace in the Sun's core. The energy from the fusion of hydrogen into helium pushes outwards, holding the star up against its own gravitational collapse. For 10 billion years, this is the Sun's quiet and noble struggle, an eternal internal war between gravity and light. A war in which both sides are perfectly matched, resulting in a long and beautiful peace. But now, 5 billion years in our future, we arrive at the moment that this ancient truce is finally broken. After 10 billion years of continuous and faithful work, the great nuclear furnace in the very heart of the Sun has consumed the last of its primary fuel. The final available atoms of hydrogen in the core have now been fused into helium. The engine that had powered the solar system for its entire history, the engine that had held the great weight of the Sun at bay for eons, has now, for the very first time, sputtered and falling silent. With the fusion furnace in the core now extinguished, the great outward pushing pressure that it generated disappears. And for the first time in 10 billion years, the colossal inward crushing force of gravity is now unopposed. And gravity, the most patient and relentless of all the cosmic forces, begins to win. The great balance is broken, and the heart of the Sun, its now inert core of helium ash, begins to collapse under its own, almost unimaginable weight. This is a quiet and an internal crisis. From the outside of the Sun, at first, very little would appear to change. But deep within its hidden heart, a dramatic and catastrophic event is unfolding in majestic slow motion. The helium core, no longer supported by the fires of fusion, begins to shrink. The immense weight of the Sun's outer layers, the hundreds of thousands of miles of hydrogen and helium plasma, now bears down on this central, dead core, compressing it with a force that is difficult to comprehend. As the core is crushed, its density and its temperature begin to skyrocket to levels far, far hotter and denser than they ever were during the Sun's long and stable life on the main sequence. It becomes a small, incredibly hot, and degenerate ball of helium, a kind of stellar ember at the very center of the star. This silent, inward collapse of the star's core is the true and definitive moment of the Sun's death as a main sequence star. Its long, peaceful, and life-giving adulthood is now officially and completely over, and its dramatic, turbulent, and spectacular old age has now irrevocably begun. This great gravitational collapse is not an ending in itself. It is the seed of the next and far more spectacular phase of the Sun's life. The quiet and final death of the old engine in the core is the very act that will, in a moment of beautiful and violent paradox, ignite a new and far more furious fire in the layers that surround it. The Sun is about to be reborn into its second life, and its new form will be that of a great and terrible cosmic giant. We have arrived at the great turning point in the life of our star. After 10 billion years of faithful, steady service, the hydrogen fuel in the very heart of the Sun has been exhausted. The great engine of core fusion has fallen silent And in that silence, the relentless inward crushing force of gravity has taken over, compressing the now dead helium core into an incredibly hot and unimaginably dense stellar ember. This is the quiet and internal crisis that marks the end of the sun's long and peaceful life on the main sequence. But this ending is not a simple fade to black. It is, in a beautiful and violent paradox, the very trigger for a new and far more furious kind of fire. The death of the old sun is about to give birth to the new. To understand this fiery rebirth, we must remember the structure of our star. For its entire life, the only part of the sun that was hot and dense enough to sustain nuclear fusion was its very core. Surrounding this now exhausted core is a vast, thick, and previously untouched shell of pristine hydrogen gas. This is a colossal reservoir of unburned fuel, a volume of hydrogen many times larger than the original core itself, which has been sitting there, dormant, for the past 10 billion years. And it is this shell of virgin fuel that is now destined to become the engine of the sun's spectacular old age. The process is one of simple and inevitable consequence. The collapsing helium core, with no fusion to support it, becomes smaller and smaller and hotter under the immense weight of the star. Its temperature soars, far beyond the 15 million degrees of its life on the main sequence. It becomes a kind of cosmic hot plate, a white-hot ember at the very center of the sun, radiating an almost unimaginable amount of heat into the layers of gas that are directly above it. And as the helium ash core collapses and heats up, it raises the temperature of the adjacent hydrogen layer enough to ignite hydrogen shell burning. This new fire lights up in a thin, spherical shell surrounding the inert helium core, at temperatures well below the 100 million degrees that are required for helium fusion. This new process is known as hydrogen shell burning. The engine of the sun has, in a sense, moved. Fusion is no longer happening in the very center of the star, but in a thin, spherical shell that surrounds the dead, collapsing helium core. And this new fire is a far more ferocious and far more powerful one than the old gentle fire of the sun's youth. It is burning at a much higher temperature and at a much higher pressure, and so the rate of the fusion reaction is dramatically and violently increased. The sun, which for 10 billion years had been sipping its fuel with a slow and patient grace, now begins to gulp it down at a furious and prodigious rate. The amount of energy that is now being produced by this thin, hydrogen-burning shell is colossal, many, many times greater than the energy that was ever produced by the old core-burning engine. And this is the moment that the great and ancient balance is shattered forever. For 10 billion years, the gentle outward push of the core's fusion was in a state of perfect and delicate equilibrium with the inward crush of gravity. But now, this new, supercharged, and incredibly powerful shell of fusion is producing a tidal wave of outward pressure, a furious gale of energy and radiation that the steady, familiar force of gravity can no longer contain. The outward force now completely and utterly overwhelms the inward pull. The great ancient truce is over, and the vast outer layers of the sun, the hundreds of thousands of miles of plasma that make up the bulk of the star, now have no choice but to respond to this new, immense, and overwhelming outward push. They begin to expand, and they will continue to expand, and expand, and expand, in a slow, majestic, and unstoppable process that will unfold over the next 100 million years. This is the birth of the red giant, the quiet internal crisis at the very heart of the sun. The silent collapse of its dead core has now triggered a furious and spectacular new life in the shell around it, and the consequence of this new furious life will be a great and final swelling, a last magnificent act of expansion that will change the face of our entire solar system and seal the final fiery fate of our own long-dead planet Earth. The great ancient balance at the heart of our sun is now broken. For 10 billion years, the inward crush of gravity and the outward push of nuclear fusion were locked in a perfect and delicate stalemate, giving our solar system a long and beautiful era of peace and stability. But now, the fire in the sun's core has died, only to be replaced by a new and far more furious fire in a shell that surrounds it. This new, supercharged engine of hydrogen fusion is now producing a colossal and overwhelming outward pressure, a great and final exhalation of energy that gravity can no longer contain. And so, the great and final transformation begins. Our sun, the familiar, life-giving friend of our world, now begins its slow and majestic expansion. It is on its journey to becoming a red giant. This is not a sudden or an explosive process. It is a slow and almost graceful swelling that will unfold over the course of many millions of years. The vast outer layers of the sun, which make up the majority of its volume, begin to push outwards, expanding into the cold, empty space of the inner solar system. Slowly, inexorably, the familiar, sharp, and brilliant disk of the sun that we know begins to grow larger and larger in the sky as it expands. A strange and beautiful paradox occurs. Even though the sun's new internal engine is burning hotter and producing far more total energy than ever before, its visible surface actually begins to cool down. This is because that same immense amount of energy is now being spread out over a much, much larger surface area. It is like taking the heat from a single, small, and intensely hot light bulb and using it to power a glowing panel that is the size of a house. The panel will be luminous, but it will not be intensely hot to the touch. The sun's surface temperature will drop from its current familiar 6,000 degrees Celsius down to perhaps only 3,000 or 4,000 degrees. And as the surface cools, its color begins to change. According to the fundamental laws of physics, hotter objects glow with a blue or a white light, while cooler objects glow with an orange or a red light. And so, as the sun's surface cools and expands, its brilliant yellow-white color will slowly shift, first to a deep and burnished gold, then to a beautiful and ominous orange, and then, finally, to the deep, dull, and ruddy glow of a true red giant. The scale of this new star is almost impossible to comprehend. As its expansion continues, the sun will swell to become more than 100 and then 200 times its current diameter. It will become a colossal and yet very tenuous star. Its outer layers will be a vast and almost transparent low-density gas, a great, fuzzy, and diffuse ball of glowing red light that does not have the sharp, well-defined edge of our current sun. This new, colossal star will now begin to reclaim the children that it gave birth to billions of years before. The first of the planets to meet its end will be Mercury. The shimmering, expanding, and fiery edge of the sun's new atmosphere, its photosphere, will reach out across the 58 million kilometers of empty space, and it will touch the small, scorched, and airless world. Mercury, the fastest and innermost of all the planets, will have nowhere left to run. It will be slowly and gently consumed, its rock and its metal vaporized by the incredible heat, its substance dissolving back into the substance of the star that created it. Next, it will be the turn of Venus. The great red giant sun will continue to swell, its expanding surface now stretching out more than 100 million kilometers from its core. It will reach the orbit of Venus, and our planet's so-called sister world, with its thick and toxic atmosphere, will also meet its fiery end. It too will be vaporized and will become one with the great expanding star. The sun of our main sequence, the familiar, life-giving star that has defined our every moment of existence, is now gone forever. In its place is a colossal, a cooler, and a deep red star, a ghostly and magnificent giant that has already consumed its two innermost children, and its expanding, ruddy surface is now looming ever closer to the orbit of our own long-dead and waiting Earth. We have now witnessed the great and profound transformation of our sun, the quiet and stable yellow-white star of our own time. The star that has nurtured our world for billions of years is gone. In its place, a new and colossal star has been born from its ashes. The furious and supercharged engine of its hydrogen-burning shell has pushed its outer layers outwards, swelling it into a great and magnificent red giant, a star that has already consumed its innermost children, Mercury and Venus. And now, for this part of our journey, we must turn our gaze back to our own home. Let us travel in our minds to the surface of our own, now long-dead Earth, and witness what this new sky would look like. Let us stand, as silent and imaginary observers, on the scorched and sterile rock of our home world, and look up at the final and most spectacular sunset in the history of our planet. The first and most overwhelming impression would be one of sheer and impossible scale. The sun is no longer a small, brilliant disk that you can cover with your thumb. It is no longer a familiar object in the sky. It has become the sky. The great, ruddy, and crimson sphere of the red giant sun would now fill a colossal portion of our view, a wall of light and of fire that would stretch from one horizon to the other. Its presence would be absolute, an all-consuming and inescapable fact of existence. We would feel as though we were no longer orbiting a star, but were instead floating just a few miles above the surface of a great celestial ocean of fire. And the light that this new sun casts is a light of a completely different character. It is not the bright, warm, and hopeful yellow-white light of our own era, a light that illuminates a world of blues and greens and whites. The light from this great, cool, and expanded star would be a deep, a dim, and a somber crimson. The entire barren landscape of our dead Earth, its empty ocean basins, its eroded, mountainous bones, would be bathed in this eternal ruddy twilight. It would be a world painted only in shades of red, of deep and burnished orange, and of profound, black shadow. It would be a world of a final and unending sunset. The very texture of this new sun would be different. Our own sun has a sharp and definite edge, a perfect, brilliant circle that we are taught never to look at directly. But a red giant is a much more tenuous and diffuse object. Its outer layers are a vast and almost transparent, low-density gas. And so, the great red sun in our sky would not have a sharp edge. Its boundaries would be fuzzy and indistinct, its glowing, crimson light bleeding softly into the blackness of space. Although the red giant's outer layers are diffuse, they are still optically thick. The bright inner regions remain hidden, and the star shows no sharp edge, just a vast, softly fading glow. And this star is not a quiet or a static object. A red giant has a powerful but very slow stellar wind. As we stand on the surface of our dead Earth, we would be, in a very real sense, inside the outermost parts of the sun's own expanded atmosphere. We would witness great, slow-moving rivers of luminous gas, ghostly sheets and tendrils of the sun's own substance, flowing past our world on their journey out into the deeper solar system. The sky would be filled with these slow, majestic, and silent currents of celestial fire. The experience on the surface of the Earth itself would be one of profound and absolute desolation. We are standing on a world that has already died billions of years before from the sun's slow brightening. But now, In the face of this colossal, nearby giant, the conditions are truly extreme. The heat is so intense that the very rock beneath our feet would be glowing with a faint, dull red of its own. The surface of the Earth would be a sea of molten magma, its oceans of water long gone, replaced by oceans of liquid rock. Any last trace of our own civilization would have been melted, vaporized, and erased from existence. And in this world of fire and of silence, there would be a profound and an absolute quiet. The atmosphere of our world, our great blue sky, would have been stripped away and boiled off into space long ago. And so there would be no wind, there would be no sound. The entire spectacular and terrifying drama of our star's death would unfold in a perfect and a total silence. It is a vision of the end of all things, a truly apocalyptic scene. And yet, it is also a vision of a strange, a terrible, and a majestic beauty. It is the final and most intimate view of our parent star that our planet will ever have. It is a final, silent, and fiery embrace, and it is a prelude to the Earth's own final question. Will it, like Mercury and Venus, be consumed by this great and fiery giant, or will it survive as a burnt and blackened cinder to witness its final, ghostly acts? We have now stood, in our shared imagination, on the molten, blackened surface of our home world, 5 billion years in the future. We have looked up and have witnessed the most spectacular and terrifying sky imaginable. A colossal, fuzzy, and deep red sun that fills our entire view. A great, silent ocean of fire that has already consumed the inner worlds of Mercury and Venus. We have seen our Earth sterilized, its oceans boiled away, its atmosphere stripped and lost to space. Its very rock superheated to a glowing ember. The story of life on Earth is long over. But the story of the planet Earth itself, as a physical object, now faces its final and most profound question. Will it survive this fiery embrace? Or will it, like its inner siblings, be completely consumed, its substance return to the star that gave it birth? The answer lies in a great and delicate cosmic race, a contest between the sun's expansion and the slow, graceful shifting of our own world's orbit. The first and most intuitive part of the answer seems simple and unavoidable. At its largest, during its red giant phase, our sun is predicted to swell to a size that is approximately 256 times its current radius. This would expand its visible surface to a point that is almost exactly 1 astronomical unit from its center. 1 astronomical unit is the current distance of the Earth's orbit. From this simple calculation, the fate of our planet seems sealed. The expanding edge of the sun will reach our orbit, and the Earth will be engulfed. It seems to be a simple and a fiery end. But the story, like all stories in the cosmos, is more subtle and more beautiful than that. As the sun swells into a red giant, it is also undergoing another profound change. It is beginning to lose a significant amount of its own mass. In its final phases of life, a powerful stellar wind will begin to blow from its surface, carrying vast quantities of its own substance, its hydrogen and helium atmosphere, out into the far reaches of the solar system. By the time it reaches its maximum size, the sun may have lost as much as a third of its total mass. And this great cosmic weight loss has a direct and powerful consequence for all the remaining planets. The gravitational grip that a star has on its planets is directly proportional to its mass. As the sun becomes less massive, its gravitational pull on all the worlds in its family, from the burnt cinder of Earth to the great frozen giants of the outer solar system, will weaken. And as this gravitational tether weakens, the orbits of all the planets will begin to change. They will, slowly and gracefully, begin to spiral outwards, moving into larger and safer orbits. And so, the great cosmic race begins. The surface of the sun is expanding outwards, a great and fiery tide that is threatening to consume everything in its path. But at the same time, the orbit of the Earth, released from the sun's full gravitational grip, is expanding outwards as well, a small and desperate attempt to flee to a safer distance. The ultimate survival of our planet depends on which of these two processes is faster. Will the Earth be able to move out of the way in time? For a long time, the calculations were uncertain. It seemed that our planet might be able to escape, that it would survive, albeit as a scorched and barren rock in a new, wider orbit around its giant dying star. But in recent years, a new and more subtle factor has been added to the calculation, a final and decisive force in this great cosmic race. This force is the power of tides. Even as a red giant, the sun's immense gravity will continue to exert a powerful tidal force on the Earth. It will raise great tidal bulges on our planet's molten, rocky surface. And because the Earth will still be spinning, these tidal bulges will create a subtle but immensely powerful drag on our planet. This tidal drag will act as a brake, slowing the Earth down in its orbit. And as the Earth slows down, it will lose orbital energy. The gentle outward spiral caused by the sun's mass loss will be halted and then reversed. The tidal drag will be the winning factor, and it will begin to pull our world slowly and inexorably inwards. And so, we have our final, quiet, and somber answer. The Earth will not escape. After being sterilized by the sun's slow brightening, and after being scorched and melted by the intense heat of the red giant, its final act will be a slow and graceful spiral inwards. It will be pulled closer and closer to the colossal red star, until it finally crosses the threshold of its outer atmosphere, and, like Mercury and Venus before it, it will be consumed. The rock and the metal of our world will be vaporized, and the very atoms that once made up our beautiful blue planet will be returned to the substance of the star that first gave them form. The story of the planet Earth will, at last, be over. We have now borne witness to the final, fiery fate of our own homeworld. We have seen our Earth and its inner siblings consumed by the great and silent expansion of our dying star. The story of the planets of the inner solar system is now complete. And so, we must now return our gaze to the central character of our story, the great red giant sun itself. For its own personal and profound drama is far from over. It has become a colossal, luminous, and relatively cool star. Its great, ruddy atmosphere stretching out almost to where the Earth once orbited. But deep within this vast and tenuous giant, at its very heart, the next great act of its life is about to begin. The silent, collapsing core of helium ash, the dead ember left behind after 10 billion years of hydrogen fusion, is reaching its own new and spectacular moment of crisis. Let us return our awareness to the heart of the star. While the sun's vast outer layers have been expanding, its helium core has been doing the exact opposite. Under the immense and unopposed crush of its own gravity, it has been contracting, becoming ever smaller and ever hotter. For millions of years, this process has continued, the temperature and the density at the very center of the sun rising to levels that are almost impossible to imagine. The core is now in a strange and exotic state of matter known as electron degenerate. The pressure has become so great that the electrons have been stripped from their atoms and are now packed together as tightly as the laws of quantum mechanics will allow. And the temperature has been climbing past 50 million, 70 million, and now it is approaching a new and truly magical threshold. It is approaching the temperature of 100 million degrees Celsius. This is the critical flashpoint for a new kind of nuclear fire. For at 100 million degrees, the nuclei of helium, the ash of the old fire, now have enough energy to overcome their own powerful electrical repulsion, and a new and much more powerful fusion reaction begins. In a process known as the triple alpha process, 3 helium nuclei are able to fuse together to create a single, new, and heavier nucleus of the element carbon. For the first time, a new element has been forged in the heart of our star. The Sun has learned a new and beautiful kind of alchemy. In a larger and more massive star, the ignition of this new helium-burning fire would be a relatively gentle and a stable event. But in a star like our Sun, with its strange, degenerate core, the ignition is a far more dramatic and a far more violent affair. The strange property of this degenerate matter is that its pressure does not increase as its temperature rises. This means that as the helium fusion begins and starts to release a colossal amount of new energy, the core cannot expand and cool itself down to find a stable balance. And so, the reaction becomes a runaway, thermonuclear event. This is the helium flash. For a few brief minutes, the very heart of our Sun will erupt in a flash of fusion that is almost unimaginably powerful. The core's energy output during this flash will soar to billions to tens of billions of times the Sun's current luminosity, immense enough to reshape the core's state, yet completely veiled from view by the star's outer layers. And yet, this entire spectacular and galaxy-bright conflagration is happening deep within the heart of the star, its immense and violent energy completely absorbed by the vast, thick, and tenuous outer layers of the red giant. From the outside, nothing would be seen. It is a silent, a secret, and a galaxy-shattering event that happens in the most hidden and private chamber of the star. The immense energy released by the helium flash is, however, finally enough to break the strange, degenerate state of the core. The core is now so hot that it begins to behave like a normal gas again. It expands, it cools slightly, and it settles down into a new, a stable, and a much gentler state of helium fusion. And this brings about another beautiful paradox in the life of our star. The ignition of this new, more powerful, and deeper fire in its core causes the Sun as a whole to undergo a dramatic change. It begins to shrink. The immense outward pressure from the old hydrogen-burning shell is now better counteracted by a new, stable, and self-regulating core. And so the Sun will pull its vast, extended atmosphere back in. It will shrink from its colossal, red giant size, becoming a much smaller and much more compact star. As it shrinks, its surface temperature will increase, and its color will shift toward a warmer orange, more compact and steadier than at the red giant peak. It has been reborn. The Sun now enters a quiet and stable second life, the red clump phase, the metal-rich counterpart of the horizontal branch, that will last for about 100 million years. It is a brief but a gentle Indian summer in the long life of our star. But its new helium fuel is a much richer and more powerful one, and it will be consumed at a much faster rate than the hydrogen of its youth. The story of its death is not yet over. This is just a brief and a quiet interlude before the final and even grander expansion is to come. We have left our Sun in a state of brief and quiet second life. After the great and silent cataclysm of the helium flash in its core, it has settled into a new and stable equilibrium. It has shrunk from its first colossal red giant phase, and for about 100 million years, it has shone as a smaller, hotter, and more stable star, calmly and patiently fusing helium into carbon and oxygen in its reborn heart. This is a quiet and gentle Indian summer in the long life of our star, but this new, stable life is a fleeting one. The Sun's new helium fuel is a much richer and more potent one, and it is being consumed at a much, much faster rate than the hydrogen of its youth. And so, after a mere 100 million years, a brief moment in the 10 billion year life of the star, this new helium fuel in the core is also finally and completely exhausted. The second engine has now fallen silent. And the sun is now ready to begin its final, its most spectacular, and its most beautiful act of transformation. The story of what happens next is, in a sense, a beautiful and more complex echo of what has happened before. At the very center of the sun now lies a new and final inert core. It is a small, incredibly dense, and incredibly hot ball of carbon and oxygen, the ash that was created by the helium fusion of the sun's second life. For a star of our sun's modest mass, the force of gravity will never be strong enough to crush this carbon-oxygen core to the point where it can ignite a new and even more powerful fusion reaction. This is the final and the ultimate stellar ember. The sun's long history of creating new elements in its heart is now over. And so, for the second time, the great and patient force of gravity becomes the unopposed ruler of the sun's core. The carbon-oxygen heart of the star, with no fusion to support it, once again begins to contract and to heat up under its own immense weight. And as this final dead core heats up, it ignites the layers of unburnt fuel that surround it, just as it did before. But this time, the situation is more complex and far more powerful. The immense heat from the contracting carbon-oxygen core ignites a new shell of fusion in the layer of helium that is directly touching it. The sun now has a helium-burning shell, and the immense heat from that new helium-burning shell, in turn, reignites the old dormant shell of hydrogen that lies just outside of it. The sun has now evolved into a new and truly extraordinary kind of star. At its center is a dead and shrinking core of carbon and oxygen. Surrounding that is a thin and furiously burning shell of helium. And surrounding that is another, slightly cooler, but still intensely burning shell of hydrogen. The sun now has two concentric nuclear furnaces, both burning at the same time. This is the star's final and most powerful configuration. This is a phase of life known to astronomers as the asymptotic giant branch. The combined energy output from these two powerful and unstable burning shells is now truly colossal, far greater than any energy the sun has ever produced before in its long life. And this immense new outward-pushing pressure once again completely overwhelms the force of gravity. And so, the sun begins to expand for a second and a final time. It swells once more into a great and magnificent giant, becoming even larger and far more luminous than it was during its first red giant phase. But this new giant star is not a stable one. The two thin burning shells are incredibly sensitive to tiny changes in temperature and pressure, which causes the star to undergo a series of great and rhythmic thermal pulses. During these pulses, which can last for a few thousand years, the star's brightness can change dramatically. This deep internal instability has a profound and beautiful effect on the star's vast outer layers. It begins to drive a new and much more powerful stellar wind. The star, in its final and turbulent old age, begins to gently but massively puff away its own vast atmosphere of hydrogen and helium out into the cold and empty space that surrounds it. This is a quiet, a majestic, and a beautiful process of letting go. The sun is now in the process of its last great farewell. It is shedding its own skin, its own substance, the very material that it has held onto for more than 10 billion years. And this gentle but immense river of gas that is now flowing away from the dying star is the raw material, the beautiful and ghostly substance from which the sun will build its final and its most beautiful monument. We have now accompanied our sun into its final, magnificent, and turbulent stage of life. It has become a colossal and unstable giant, its heart a complex engine of two concentric shells of nuclear fire. We have seen how this deep internal instability is now driving a powerful but gentle stellar wind, a great and final exhalation that is puffing the sun's own vast outer atmosphere away into the cold and empty space of the solar system. For tens of thousands of years, this quiet and majestic process continues. The sun is letting go. It is shedding the beautiful gaseous robes that it has worn for more than 10 billion years. And it is this final, graceful, and generous act of surrender that will create the sun's last and most beautiful monument. This is the story of the birth of its cosmic ghost, the breathtakingly beautiful phenomenon known as a planetary nebula. As the slowing, steady stellar wind carries the sun's outer layers away, they form a vast and ever-expanding shell of gas around the central star. This cloud of gas is at first completely dark and invisible. It is a ghost in waiting. But as the outer layers are stripped away, something that has been hidden for billions of years is finally, for the first time, revealed. At the very center of this expanding cloud, the tiny, incredibly hot, and incredibly dense core of the sun is unveiled. This is the small, Earth-sized ball of carbon and oxygen, the final inert ember of the sun's long life of nuclear fusion. And this newly exposed core is searingly hot, with a surface temperature of more than 100,000 degrees Celsius. And as the light from this incredibly hot naked core streams out into space, it strikes the expanding cloud of gas that the star has just shed. The intense, high-energy ultraviolet radiation from the core slams into the atoms of hydrogen and helium in the cloud, and a beautiful and magical process occurs. The radiation energizes the atoms in the gas, stripping away their electrons and causing them to fluoresce. The dark, invisible cloud of gas is suddenly and spectacularly set ablaze with a brilliant, multicolored, and ethereal light. This magnificent, glowing, and ever-expanding jewel of gas is a planetary nebula. The name, we must say, is one of the most beautifully misleading in all of astronomy. These objects have absolutely nothing to do with planets. They were given their name by early astronomers like William Herschel, who, through their small and primitive telescopes, saw these distant, glowing objects as small, faint, greenish-blue disks, and thought they looked very much like the newly discovered planets, Uranus and Neptune. But they are not planets. They are the final, and most beautiful, artwork of a dying, sun-like star. They are the tombstones of a star, but they are tombstones that are made of pure and glorious light. And they are among the most beautiful and intricate objects in the entire cosmos. A planetary nebula is not just a simple spherical bubble of gas. The slow, steady wind of the dying star, combined with its magnetic fields and the complex physics of its rotation, sculpts the expanding gas into breathtaking and often symmetrical shapes. Some form beautiful, perfect circles, like the magnificent Ring Nebula, a celestial smoke ring puffed from a dying star. Others are pinched at the waist by a dense disk of dust, and the gas is forced out in two great opposing lobes, forming the ghostly and beautiful shape of a cosmic hourglass, like the Southern Crab Nebula. And some of the most spectacular of all are shaped by multiple, complex jets of gas, forming intricate, multi-layered, and nested structures that can look like a great cosmic eye staring back at us from across the void. The colors of these cosmic ghosts are a beautiful form of chemical storytelling. Each different gas, when energized by the central star, glows with its own unique and characteristic color. The most abundant gas, Hydrogen glows with a deep and familiar ruby red light. Oxygen, a much rarer element forged in the heart of the star, glows with a beautiful and ethereal greenish-blue light. Nitrogen and other elements add their own fainter hues to the cosmic palette. To look at a color photograph of a planetary nebula is to see a chemical map of the star's own legacy, a final, beautiful display of all the new and precious elements that it has created in its long life. But this spectacular and beautiful display is an incredibly brief and fleeting one. A planetary nebula only glows for about 10 to 20,000 years. In the grand cosmic timescale of a star's life, this is the equivalent of a single, brilliant, and final firework, a momentary flash of glory before the end. After this short period, two things happen. The central remnant star has cooled down too much to produce enough high energy, ultraviolet radiation to light up the cloud, and the gas cloud itself has expanded so much. Its atoms now spread so thinly that it simply fades away, its beautiful colors dissolving back into the cold and invisible darkness of the interstellar medium. It is the sun's final, beautiful, and most generous act, a last, quiet, and graceful exhale, a fleeting monument of light to mark the end of its long and magnificent life. The final, beautiful, and most generous act of our sun's life is now complete. For a brief and glorious period of 10,000 years, it has illuminated the cosmos with the intricate and multicolored light of its own celestial ghost. The planetary nebula, that magnificent and glowing monument made from the sun's own shed skin, has now expanded and cooled and thinned to the point of invisibility. Its beautiful, ethereal light has faded, and its substance has now begun to merge back into the great, dark, and silent ocean of the interstellar medium. The ghost has vanished, and now, as the last, faint whispers of its colorful light disappear, we are left to turn our attention to the object that remains at the very center of this new and final solar system. We are left to contemplate the stellar corpse, the final and almost eternal remnant of the star that once gave us life. This object is known as a white dwarf. After the great and final expansion of its last giant phase, and after the gentle but complete expulsion of its outer atmosphere, all that is left of our once great sun is its exposed, inert, and incredibly dense core. This is the white dwarf. And the first thing we would notice about this new and final object is its almost impossible scale. It is incredibly small. The sun, which was once almost 1,000,000 miles in diameter, has now been reduced to a sphere that is approximately the same size as the planet Earth. But into this tiny Earth-sized volume, a colossal amount of mass has been crushed. The new white dwarf sun contains about 60% of the sun's original mass, all of it packed into a space that is almost 1,000,000 times smaller. The result of this incredible compression is a density that is unlike anything we know of in our everyday lives. The matter of a white dwarf is so incredibly and so densely packed that a single small teaspoon of its substance, if you could somehow bring it to Earth, would weigh more than 15 tons. It would weigh as much as 3 fully grown elephants. It is a state of matter so extreme, so alien, that it seems it should not be able to exist at all. And this raises a quiet and profound question. If the great outward-pushing fire of nuclear fusion has now been extinguished forever, and the only force left is the immense and now unopposed inward crush of gravity, then what is stopping this Earth-sized ball of super-dense matter from collapsing even further? Why does it not continue to collapse until it becomes an infinitely dense black hole? The answer is that the white dwarf is being held up by a new, a strange, and a profoundly powerful force, a force that is not born from heat, but from the very fundamental rules of the quantum realm. The star is now being supported by electron degeneracy pressure. To understand this, we must picture the atoms in the star's core. They have been crushed with such incredible force that their electrons have been stripped away, forming a kind of super-dense, free-floating sea of electrons. And these electrons, because they are quantum particles, must obey a strange and beautiful rule known as the Pauli exclusion principle. This principle states in a very simple sense that no two electrons can ever occupy the exact same quantum state, the same energy level in the same space. You can think of it like a great cosmic concert hall with a limited number of seats. Gravity is the usher, trying to force the entire audience of electrons into a smaller and smaller section of seats. But the electrons resist. They refuse to sit in a seat that is already occupied. And this quantum stubbornness, this fundamental refusal of the electrons to be crushed on top of one another, creates a powerful and outward-pushing pressure. This is electron degeneracy pressure. And it is this force, a force born not from energy, but from a fundamental rule of quantum mechanics, that finally and permanently halts the gravitational collapse of the star. The White Dwarf, then, is a new and a final kind of star. It is in a state of a new and an eternal equilibrium, and when it is first born, from the heart of its fading planetary nebula, it is incredibly hot. Its surface temperature is more than 100,000 degrees Celsius, many times hotter than the surface of our current sun. And because of this intense heat, it glows with a brilliant and a beautiful white or even slightly bluish light. But it is crucial to understand that it is no longer a true star. It is not generating any new energy. The fires of fusion are out forever. It is, in a sense, just a stellar ember, the hot coal that has been pulled from the great cosmic fire, and it is shining only with its own leftover residual heat, the immense thermal energy that it has stored up over its long and dramatic life as the core of a star. This is the final, stable form of our sun, a silent, a beautiful, and an incredibly dense, diamond-like jewel, shining brilliantly in the center of its own beautiful and now faded cosmic tomb. We have now witnessed the birth of our sun's final and most enduring form, the great and dramatic acts of its life, the 10 billion year piece of the main sequence, the colossal expansion of the red giant phase, and the brief, beautiful, and ghostly farewell of the Planetary Nebula are now all in the past, at the quiet center of our new and mostly empty solar system. A single, strange, and beautiful object now remains. It is a white dwarf, the super-dense, Earth-sized, and incandescently hot stellar corpse of our star. It is a monument of carbon and oxygen, a diamond in the dark, held up against the final, crushing force of gravity by the strange and powerful laws of the quantum realm. And it is shining with a brilliant white light, a light that is born not from any new fire, but from the immense leftover heat of its own long and dramatic life. And so we come to the final, the longest, and the quietest chapter in the entire story of our sun. This is the story of its long and gentle twilight. This is the story of its final and almost eternal cooling. A newly born white dwarf is one of the hottest objects in the universe, with a surface temperature that can exceed 100,000 degrees Celsius. But it is an object that is living on borrowed time. It has no internal source of energy. It is no longer a true star. It is, in the simplest sense, a cosmic ember, the hot coal that has been pulled from the great stellar furnace. And like any ember, once it is removed from the fire, it can only do one thing: it must cool down. But the process of cooling for a white dwarf is one of almost unimaginable slowness. There are two simple reasons for this incredible patience. The first is that the white dwarf has an immense amount of heat stored in its incredibly dense, small body. The second is that it has a very, very small surface area from which to radiate that heat away into space. Imagine taking a hot cup of tea and pouring it out onto a large, flat dinner plate. The tea on the plate will cool down very quickly because its heat can easily escape from its large surface area. Now, imagine taking that same hot cup of tea and pouring it into a tiny, perfectly insulated thermos flask, the size of your thumb. The tea in the thermos would stay hot for an incredibly long time because it has only a tiny opening from which to lose its heat. A white dwarf is the ultimate cosmic thermos, and so its final journey, its slow descent into the cold and the dark, is a journey that will last for trillions of years. Let us now travel forward into this deep and quiet and almost unimaginable future. For the first few billion years of its new life, our white dwarf sun will still be incredibly hot and bright. It will have cooled from its initial brilliant blue-white to a more familiar, steady white, and then eventually to a soft golden yellow, not unlike the color of our sun today, though it will be a tiny, star-like point in the sky of its remaining planets. For billions of years, it will continue to pour a gentle but significant amount of light and heat into the surrounding darkness. But the slow cooling is relentless. After tens and then hundreds of billions of years, its surface temperature will have dropped significantly. Its color will continue to shift down the spectrum, from yellow to a deep and burnished orange, and then eventually to a dim and moody red. In this distant future, the great giant planets like Jupiter and Saturn will still be silently orbiting this tiny, fading red ember. But the light it casts upon them will be a faint and ghostly twilight, a pale and ancient memory of the brilliant sunlight they once knew. Onward we travel into a future so deep that the very concept of time begins to lose its meaning. After 1 trillion years have passed, a span of time that is almost 100 times the entire current age of our universe, our white dwarf will have cooled so much that its light will have faded from the visible spectrum entirely. It will no longer shine with a visible light. It will be an object that glows only with a faint and feeble, invisible, infrared heat. The solar system will now be completely and totally dark. And the journey continues into the almost eternal silence. After hundreds of trillions and then quadrillions of years, our white dwarf will have finally radiated away the very last of its residual heat. Its long and patient twilight will be over. Its temperature will have finally reached a state of perfect and final equilibrium with the cold background temperature of the empty and by now ancient and dying universe. It has reached its final form. It has become a black dwarf. This is a cold, a dead, and a completely invisible ball of degenerate carbon and oxygen, the size of the Earth, drifting silently and eternally in the final dark era of the cosmos. It is the final perfect and unobtrusive ghost of our once great sun. And because this cooling process is so incredibly and so unimaginably long, so much longer than the current age of the universe, we can say with a quiet confidence that there are, as of yet, no black dwarfs anywhere in our entire cosmos. They are objects that belong only to the very deepest and the very quietest of all possible futures. We have now followed the long and quiet story of our sun to its final and almost eternal conclusion. We have accompanied it on a journey that has spanned not just billions, but trillions and quadrillions of years into the deep and silent future. We have seen its brilliant, white-hot birth as a white dwarf, and we have witnessed its slow and patient fade, a trillion-year twilight that will end with it becoming a cold, a dark, and an invisible black dwarf. A final and perfect stellar ghost, drifting silently in the last dark era of the cosmos. The story of the sun itself, as a single physical object, is now complete. And it is a story that can feel, at first, like a somber and a lonely one, a tale of a great and brilliant light, slowly and inevitably fading into an endless and an absolute darkness. But this is not the true end of our star's story. For the sun's greatest and most enduring legacy is not the cold, dead ember that it will leave behind. Its true legacy is written in the beautiful and life-giving substance that it gave away in its final, most generous, and most beautiful act. Let us travel back in our minds, for a moment, to that brief and glorious period in the sun's death, the fleeting 10,000-year-long spectacle of the Planetary Nebula. As we learned, in its final, unstable giant phase, the sun gently puffed away its vast outer layers. The great envelope of hydrogen and helium that had been its body for more than 10 billion years. And this expanding cloud of gas, when it was lit up by the hot central core, created one of the most beautiful objects in the entire cosmos. But the beauty of the Planetary Nebula was a temporary and a fleeting one, and its true and lasting importance is not in its light, but in its very substance. This great, expanding cloud of gas is not just the primordial hydrogen and helium that the sun was born with. It has been enriched. It has been seeded with the new and precious and life-giving heavy elements that were forged deep within the sun's heart during its long and patient life of nuclear fusion. As the sun burned through its helium fuel in its brief second life, it created a vast core of new and heavier elements. It created carbon, and it created oxygen, and in the final turbulent pulses of its giant phase, the great churning convection currents dredged up this newly forged material from the core and mixed it into the outer layers of the star. And so, the gas that was gently puffed away to form the Planetary Nebula was a gas that was now rich in the very elements that are the absolute and essential foundation of all life as we know it. And as the Planetary Nebula expands and cools and fades, this precious, enriched material does not simply disappear. It begins a new and a quiet journey. It mixes with the vast, cold, and dark clouds of gas and dust that drift in the great, empty spaces between the stars, the interstellar medium. The sun, in its death, is performing a final and a sacred act. It is an act of cosmic farming. It is carefully and generously enriching the soil of the galaxy, seeding the great, scale clouds of the cosmos with the new and life-giving elements that it has spent its entire long life creating. And this is the beautiful and profound secret of the cosmic life cycle. The death of a star is a necessary and an essential part of a great and an unending story of cosmic birth, death, and rebirth. For it is from these great, dark, and newly enriched clouds of interstellar gas and dust that the next generation of stars and planets will be born. The sun's beautiful, ghostly nebula will one day, millions of years in the future, become part of a new stellar nursery. And a new star, a second-generation star, will be born from this recycled material. And the planets that form around that new star will be born with the precious gift of carbon and of oxygen, and of all the other heavy elements that our sun has bequeathed to the cosmos. This is the great and beautiful story of our own existence. The very atoms that make up our planet, and that make up our own bodies, were themselves forged in the hearts of ancient and long-dead massive stars that lived and died billions of years before our own sun was ever born. The famous and beautiful phrase that we are made of stardust is not a metaphor. It is a literal and a profound truth. We are the children of dead stars. And the final, beautiful story of our own sun is that it too will become a cosmic ancestor. Its death is not a final and a lonely ending. It is a necessary and a generous act of creation. The legacy of our sun is not the cold and the dark black dwarf that its core will become. Its true and its enduring legacy is the gift of its own substance, the stardust that it will contribute to the cosmos, the raw material that may, one day, billions of years in the future, find its way into the soil of a new and a living and a distant world. Our long and epic journey is now complete. We have followed the grand and beautiful biography of our own sun, from its long and peaceful life on the main sequence, through its colossal and fiery transformation into a red giant, to its final, quiet, and beautiful legacy. We have seen it create a magnificent, ghostly jewel of a planetary nebula, and we have watched its core settle into the long, patient twilight of a white dwarf. And we have learned that the death of a star is not just an ending, but a profound and necessary act of cosmic creation, a generous gift of stardust to the future of the universe. The story is now told, and its final message is one of peace and of renewal. Just as our sun will one day find its final, quiet, and eternal rest, so too can you now let go of the light and the energy of your day. The only journey that remains is the one into the gentle and restorative universe of your own sleep, a quiet place of renewal from which you will awaken, ready for your own new dawn. And so you can rest now. Let the story fade. Let the day dissolve. There is only the quiet, only the calm, and only this moment of deep and peaceful rest. The journey continues, always calmly, always at the pace of the universe.